A regular hexagonal lamina of sides 25 is lying in such a way that one of its sides on HP, while the side opposite to the side on which it rests is on VP. If the lamina makes 60° to HP, draw the projections of the lamina. Okay. In today's class, so I am going to consider two problems. So in these two problems, the plane is touching both the planes. The lamina is touching both the planes. Okay. So in this case, hexagonal lamina, one of the edge is on HP and the edge opposite to it is on VP. You can consider the example of ladder. Okay. So we are going to keep one end of the ladder on floor. Another end will be on wall. Okay, wall is the vertical plane, floor is the horizontal plane. Similarly, similar to keeping a ladder, okay, we are keeping polygonal laminas. Okay, it may be hexagon, pentagon. We are keeping laminas such similar to ladder, such that one of the edge or corner will be on HP and another corner or another edge will be on VP. Okay. So now consider this problem. Given lamina is hexagon, length of the sides is 25 It is lying in such a way that one of its sides on HP, while the side opposite to the side on which it rests is on VP. So here in this case, AB is the resting side. Okay, and side opposite to the resting side means DE. Okay, this is the side opposite to the resting side. So here you can see AB is on XY line. That means this is the resting edge. It is on HP. Okay, next I should satisfy the last condition, that is side opposite to the resting edge means so DE should be on XY. That will be satisfied in the last condition. So in case of incline, in case of touching both the planes also, we are going to follow the same change of position method. There is one more method with the help of taking profile view also we can draw. That is a different procedure. I don't go for that. Okay. So by using the same procedure which we were following from the beginning of this chapter. Okay. So same procedure we can follow, that is change of position method, and we can solve this problem. Okay. Initially, I will keep the complete lamina on HP. Since it is resting on side, I will take the resting side towards right. Then I will keep the complete lamina on HP so that in top view I am able to get the true shape of the lamina. Then I will project the views and I will get the front view. Next, satisfy the first condition. Since it is resting on HP on one of the side. Okay, so take inclination with respect to HP first, that is 60° to HP. So make this front view inclined at 60, project the points and get the second top view. Next, finally, we are going to satisfy the last condition, that is the side opposite to the side on which it rests is on VP. So on VP means on XY line and it can be seen from top view. On HP means again it is also on XY line, it can be seen from front. Okay, that's why side opposite to the resting edge which is touching VP, that is DE touching XY, is represented in the top view because this you can see from the top. Okay, next we will get the final view. So I will consider the same problem on SolidWorks and I will explain the construction procedure. Okay, I am considering the same problem. A regular hexagonal lamina of sides 25 is lying in such a way that one of its sides on HP while the side opposite to the side on which it rests is on VP. The lamina makes 60° to HP. Draw the projections of the lamina. Okay, here also first start drawing XY line. That is the first step. Next, for hexagon, you can use interior angle method or circle method. Okay, I prefer to use circle method. Okay, you can use whichever you feel comfortable for you. Okay, so my suggestion is use circle method. So since it is having 25 sides, first draw a circle having 25 mm radius. Okay, next, if it is resting on side, okay, draw a vertical line passing through center. If it is resting on corner, draw a horizontal line passing through center. Since it is resting on side, first I will draw a vertical line passing through center. Okay, after that, so use compass, this as center and 25 as radius. So cut an arc, draw an arc. Okay, next, again, so this as center and 25 as radius. I will cut one more arc. So next, this as center, draw one more arc and cut the circle by taking 25 as radius. Next, so this point as center, I will draw one more arc. Okay, after that, connect these points with scale. That means draw straight line, connecting these points. Okay, next, so I will increase the thickness of the sides. Okay, then I will name the points. Okay, so after this, so I will project the points and I will get the front view. Okay, next I will name the points on front view. So since this is front view, so observer will looking from this direction. That means A is nearer to observer, B will become invisible. When you are looking at through these 2 points F and C, F will be visible and C becomes invisible to observer. This is the position of observer, that is at the bottom on the drawing sheet. Next, E will become visible and D will be invisible. Okay, after this, next satisfy the first condition, that is it should rest on one of the sides. Now complete lamina is on HP. Now I will rotate it such that, or I will lift the lamina such that only one of the side, that is AB, will remain on XY line, and remaining lamina, okay, the lamina will make an inclination of 60° with HP. So first consider a point at any leaving convenient gap, by a 60° inclined line. Okay, after that, so measure the distance between these points. So this is center, will cut the arc. So radius will be 21.65. Next, so I will consider radial distance between A and E. Okay, next this as center and 43.3 as radius. We'll cut one more arc. Okay, next I will name these points. Okay, next, so I will project the points. Okay, after projecting points, I will name them. Okay, next I will connect these points with straight line. It means you should use scale. So then I will increase the thickness. Okay, next, so I should satisfy the last condition. Okay, that is the side opposite to the side on which it rests is on VP. So here AB is the resting side. Side opposite to this means DE. Okay, it should be on VP. On VP means in top view. DE should be on XY line. So next is, so I should satisfy this condition. So first I will locate D and E on XY line. Then I will get the remaining points. Okay, consider 2 points at a distance of 25 mm. So here you can see, so length of the side is 25. So here, if it is 25 here also the length of DE remains same. Here also it is 25 only. So I will consider 2 points on XY line at a distance of 25 mm. Okay, next, so I will name the points. So this will be D and this will be E. Okay, so after drawing line DE on XY line, next try to get the remaining points. Okay, so if you know E and D, by drawing 2 arcs you can get A and also B. Okay, but there is one more method. instead of drawing two arcs, okay, initially you can draw two perpendicular lines. Okay, here you can see you are having point A on a line which is perpendicular to D and E. Okay, there is one more perpendicular line. So on this line itself, so you will get B. So that means, so here I can draw two perpendicular lines to convenient length. Okay, next, so I will take the radial distance between E to A, and I will mark that on this line. I will get point A. Similarly, radial distance between D to B, that will be same. I will get the point. Okay, now I will measure the radial distance between E and A. It is 21.65. Okay. Now, so using compass from E, I will cut an arc by taking radius 21.5. Okay, this I will get point A. Similarly, B as center and 21.65 as radius. So I will draw one more arc. Okay, next. So this is point A and this is point B. Okay, next I will connect these two. So after getting 4 points, so now easily by drawing two arcs I can get remaining points. Okay, I know point E and A. Okay, I can get F. For that, first take the radial distance between point A and F using compass and cut an arc. Okay, now, so A as center and radial distance between A to F, I will draw an arc. Okay, next, again radial distance between A to F and D to F both are same. So A as center, taking same radial distance, I will draw one more arc. So this is point F. Next, similarly, again radial distance between BC, CD will be equal to AF1. Okay, D as center, again same radial distance, I will cut an arc. Next, B as center and radial distance 16.54. I will cut one more arc. So this is point F, this is point C. Okay, next, so I will connect these points. Okay, next, now to get the final view, so I will project the points. Point F, so from here, point F. Next, E, Next point D. Next C. Okay, next A. So it will be on XY itself. B also it will be on XY line itself. Okay, next I will name the points. A, B dash, C dash, D dash, dash. So this is also, since it is front view, A dash. Okay, next, so I will connect all the points. Okay, so this is the final answer. In the final view, you can see in front view, A dash B dash is on XY line. In top view, DE is on XY line. That means A dash B dash is on HP and DE is on VP. That is the meaning. So on HP can be seen from front, on VP can be seen from top. Okay, if you have any doubt regarding this problem, you can ask questions. Okay, if you have understood everything, I will move on to next problem. Next, similar problem. Instead of hexagon, we have pentagon. A regular pentagonal lamina of 25 mm sides is resting on one of its corners on HP, while the side opposite to this corner touches VP. So here also you should keep the pentagonal lamina like ladder such that one of the corner is touching floor and the side opposite to the corner is taking support from the wall. Okay, like that you should keep the pentagonal lamina. If the lamina makes an angle of 60 degree with HP and 30 degree with VP, draw the projections of the lamina. Okay, initially keep the complete lamina on HP. Since it is resting on corner, take the resting corner towards the right, like this. Okay, so draw the pentagon and get the front view. Next, satisfy the first condition, that is inclination with respect to HP 60 degree, and get the top view. Next, so you have two conditions left. One is side opposite to this corner, that is CD, should touch VP. That means in the final view, CD should be on XY line. Okay, next 30 degree with VP. Okay, in change of position method, we cannot represent inclination with respect to VP. So if we want to represent both inclination with respect to VP and HP, we should go for one more method. That is, with the help of side view, we can represent both inclinations. But even if we don't specify that it is inclined at 30 degree, automatically it will make that inclination. Okay, you can observe. In order to understand this, you can observe the ladder. Okay, if this ladder is making 45 degree with floor, okay, automatically the ladder will make, when you keep it on wall, okay, it will make 45 degree with wall also. If the ladder is making 60 degree with floor, then it will make 30 degree with wall. Similarly here also, when it is touching both the planes, so that means one corner is on HP, another corner on VP. When the lamina is making 60 degree with HP, automatically, so the lamina also make 30 degree with VP. Okay, so need not worry about that. So when you make it inclined at 60 degree, and when you move it and when you make it touching VP. Okay, automatically it will satisfy this 30 degree with VP. That we cannot see from front or top. We can see only from side view. Okay. So this here also same procedure. First take CD on XY line. Okay, same 25 mm. So take CD. Then using compass, okay, take radial distance between D and A, cut an arc. Next take radial distance between C and D, cut an arc. You will get point A. After getting D and A, you can get E and B, like all previous problems. Okay. So later I will post it as a classwork, and you can try to solve on your own. You can get the construction procedure. Okay, solution is already available to you. So only thing is, so you can practice how to draw this on drawing sheets or on your A4 size or your notebook sheets. Okay, next last problem of this chapter, that is projection of planes. A pentagonal lamina of edges 25 mm is resting on VP with one of its sides such that the surface makes an angle of 60 degree with VP. The edges on which it rests is inclined at 45 degree to HP. Draw its projection. Okay, so this is 90% of the problems. Okay, so you most probably you are going to get a problem resting on HP. Okay, rarely you may get a problem where it is resting on VP. In such case, so you should follow this procedure. Okay, a pentagonal lamina of edges 25 mm is resting on VP with one of its sides such that the surface makes an angle of 60 degree with VP. The edges on which it rests is inclined at 45 degree to HP. Draw its projections. Okay, here after reading the problem, so given lamina is pentagon, length of the edges 25 mm, resting on VP. Okay, so all previous problems they were resting on HP. In this problem, it is resting on VP on one of its sides. Okay, so based on this, if it is resting on VP, you should keep the lamina on VP. Okay, complete lamina should be on VP so that it will become parallel to VP, and in front view you are able to see its true shape. If it is resting on HP, we will make the complete lamina resting on HP so that we can see true shape in top view. Whereas if it is resting on VP, we can see its true shape from front, that is in front view. Okay, that's why if in the problem, if it is resting on VP, we should start from front view, not top view like previous problems. Okay, in all previous problems, we started from top view, but here if it is resting on VP, we should start from front view. Okay, first draw a regular pentagonal lamina. Okay, such that you have a resting side towards the right. Draw the lamina. Okay, then project the points and get the top view. So for top view, observer position will be like this. Okay, this is the position of the observer for top view. For front view, this is the position of the observer. This is for front view in all problems. Okay, this is for top view. So when you are drawing the top view, okay, B dash, C dash and D dash will be visible since these 3 points are nearer to observer. Okay, E and A, they are farther to observer, they will become invisible. So that's why E and A inside the brackets. Okay, in the previous problem, so it is vice versa. You are looking from front. Okay, that's why which are nearer to observer are visible, farther are invisible in the previous problem. Okay, here you can see in this problem. So this is the position for top view. Okay, this is the position for front view. Observer will be looking from this direction. Now, so A, E and D. So these 3 corners are nearer to observer and they are visible, whereas B and C are invisible. Okay, similarly here, these 3 will become visible since it is top view. These 2 will become invisible. So next, so draw the front view. So here, complete lamina on VP. So in top view it looks like a line, since it is perpendicular to HP and parallel to VP. Okay, next, so after this, rotate front view. Okay, rotate top view. Okay, so in this case, so you should rotate top view. So first you will start drawing front view, then project the points, get the top view. Next, rotate the top view and satisfy the first condition, that is 60° with VP. Okay, so why we are considering inclination with respect to VP first in this problem? What is the reason? Okay, why we are considering inclination with respect to VP first? Why we are not considering inclination with respect to HP first? In all previous problems, we used to consider inclination with respect to HP first. But in this problem, we are considering inclination with respect to VP. The reason is, if it is resting on VP, first we should consider inclination with respect to VP. If it is resting on HP, we should consider inclination with respect to HP. Okay. Next, so after getting the top view, okay, so next project the points and get the second front view. Next, rotate the front view to the given inclination. That means draw a 45° inclined line on that, mark points A dash and B dash. Okay, and get remaining points, project the points and get the final view. Okay, procedure is same, but so you will start from front view. Okay, so first you will draw this view. Next you will draw this. Next from this you are going to draw this. Okay, after this you should draw second front view. Next you should draw final front view. Finally you will the procedure should follow. Okay.